planet Earth is unique. An engineering marvel driven by heat from within. The latest information from satellite maps, sonar and radar images have been brought together to create this, a virtual planet Earth. The Earth is a machine, and this is how it works. The oceans cover 3/4 of the planet's surface. Yet 90% of the seafloor has never been seen. Many of the most powerful geological processes are hidden, driven by forces deep under the oceans. Below the seafloor is uncharted territory. What we do know is that it gets warmer, much warmer. And that heat comes from something over 3,000 miles below. A giant ball of metal that spins separately from the rest of the Earth. This is the inner core. It's almost as big as the moon, and it's as hot as the surface of the sun. As we'll see, this inner core influences our lives in all sorts of ways. On Friday, 11th of March, 2011, a devastating tsunami crashed onto the coast of Japan. In some places, the waves reached over 27 meters high. The tsunami was caused by a powerful earthquake that measured 9 on the Richter scale. This was the worst earthquake to hit Japan for over 100 years. The death toll was around 25,000. This was the Earth machine in action on an awesome scale. The source of the devastation lies far beneath the surface of the ocean. The Earth machine has an incredible effect on our lives. It moves the continents, builds the biggest mountains, and creates the deepest places on Earth. This machine drives the volcanic activity on the ocean floor and the movement of the tectonic plates. The heat of the inner core drives the whole cycle of the destruction and renewal of the seafloor. To see how the Earth's machine affects the ocean floor, we need to start with the coastal waters. And the best way to see that is from above. This is the English Channel between Britain and France. The waters here are shallow, about 40 meters deep. Around the world, shallow coastal waters are a rich reserve of fish and other seafood. But 9,000 years ago, there was no sea here, and people could walk from England to France. The land is now covered by the English Channel. With modern computer technology, we can do in seconds what it takes the Earth machine thousands of years to do. As we drain the water from the beaches, a new landscape emerges. The English Channel is a busy waterway, so perhaps it's no great surprise that there are over 8,500 shipwrecks on the seabed. The history of the English Channel shows that the boundaries of the land we live on are not fixed, but can change radically. The Earth machine has the power to continually change the surface of the Earth. The Earth's crust is made up of a series of giant tectonic plates which are constantly on the move. Over time, the continents shift and sea levels rise and fall, so that what was once land sinks underwater. If we drain the oceans a bit further, to a depth of 150 meters, we can see that the edge of the continents extend far out from the shore. In some places, hundreds of kilometers. This submerged land makes up the continental shelf. This area has become one of the most valuable places on Earth, and that's because of oil. Today, many important oil fields are concentrated on the continental shelf. For millions of years, dead sea creatures and sediment from the land rained down on the seabed. With time and pressure, this debris turned into oil. And this is what has made the continental shelf so immensely valuable. Today, the large oil and gas fields on the shelf help fuel our cars, boats, and jets. Over millions of years, the movement of the continental tectonic plates around the globe created the continents as we know them today. Drain the water, leaving the shore far behind, and the edge of the continental shelf is visible. As the sea levels rise and fall, so the shelf is exposed or covered with water. The edges of the continental shelves slope down to the ocean floor. These areas are often unstable and easily eroded, and it's here we find some of the shelf's biggest features. Deep canyons. To get an idea of the scale, this is the Grand Canyon in Arizona, USA. It's over 1.5 kilometers deep, 28 kilometers wide, and over 445 kilometers long. The continental shelf is pockmarked by canyons, some even bigger than the Grand Canyon. We can't normally see these giant canyons as they're submerged under several kilometers of water, but they are one of the wonders of the deep. One of these canyons begins just a few hundred meters off the beach in Monterey Bay, California. If we drain the water from the bay, we can see this giant canyon. It's 12 kilometers wide, over 3 kilometers deep, and 470 kilometers long. Thousands of kilometers northwest of California, just off the coast of Russia, there's a canyon that makes Monterey look small. The biggest canyon on the planet is the Zemchug Canyon. It is nearly 3 kilometers deep, 233 kilometers long, and almost 100 kilometers across at its widest part. Of course, it's usually covered by the Pacific Ocean. But even so, the Zemchug is so wide, it would be impossible to see from one side to the other unless you were above the curvature of the Earth. At the edge of the continental shelf, the land meets the ocean floor. This vast area beyond the land is called the abyssal plain. It covers over half the planet's surface. For years, scientists thought it was flat and lifeless. But in the middle of the Atlantic lies one of the biggest geological features on the planet. This is where the Earth machine manufactures new seafloor. This huge mountain range is called the Mid-Atlantic Ridge. It's one of the largest, most active geological structures in the entire solar system. It's part of a vast tear in the planet's surface, a single line of underwater mountains and volcanoes that runs for over 65,000 kilometers around the planet. At the mid-ocean ridge, lava forces its way up from below. It is supplied by the mantle, a searing hot layer below the crust. This tear in the crust shows the power of the machine that drives the planet. As the lava flows out, it spreads away from the center of the ridge and cools. This continuous process produces 2.5 square kilometers of new rock every year. This new rock pushes the whole seafloor ahead of it and creates incredible stresses and strains across the seabed. This triggers earthquakes and landslides and makes deep valleys and huge undersea mountains. Following the Mid-Atlantic Ridge northwards, we come to a unique island where this vast volcano range rises out of the water. The mid-ocean ridge runs right through the middle of Iceland. Over 100 active volcanoes pepper the landscape. Iceland gives us a rare opportunity to look at the mid-ocean ridge from the inside. This part of the crack has filled with fresh water. It's called seafloor and is considered one of the most beautiful and spectacular scuba dives in the world. This is the gap between the two halves of a mid-ocean ridge. These two continental plates move apart by about 2.5 centimeters a year. This is where new seafloor was once created. A couple of million years ago, there would have been molten lava pouring up through this gap. Now it's cooled and solidified, it's left an incredible opportunity for us to see inside the mid-ocean ridge.
The Earth's crust is very thin in Iceland. In some places, it's only a few kilometers deep.
As a result, Icelanders can feel the thermal power of the Earth's machine all round the island. This heat originates in the center of the Earth and is transferred up through the mantle to the Earth's crust.
It's the heat from below that creates these geysers. The rocks below are about 200 degrees centigrade. When surface water trickles down, it enters an underground chamber about 18 meters below and boils instantly. The water expands rapidly, exploding into steam, and fires out of the hole. The boiling hot water and steam reaches about 50 meters into the air.
The same process that creates geysers here in Iceland also happens down on the seabed. Two kilometers down on the seafloor, they look like this. They're called black smokers, and they were only discovered about 30 years ago. Superheated water laced with precious minerals like gold, silver, and iron races up from the volcanic rocks below.
As they hit the cold seawater, the minerals turn black. They then solidify into chimneys that can grow up to 55 meters high.
The chimneys would be worth a fortune, but right now they're just too deep to mine. But when they began to explore these black smokers, scientists made an extraordinary discovery. They found an animal that successfully mined the black smokers for thousands of years. A metal snail. One that makes both its shell and the scales on its foot from the metals in the water around it.
The scalyfoot is the most extraordinary thing I've found.
These scalyfoot snails were discovered over 2 kilometers down on the ocean floor by Professor Cindy Van Dover.
We were sampling the large common snails, and in those handfuls of snails that we brought to the surface, we discovered these small scalyfoot snails. And we all wondered on the ship for a couple of weeks, what could they be? We didn't know. There is no other known snail that has a metal fortified shell. Even in the animal kingdom, we don't know of anything else that has a metal fortified shell. The animals have spent evolutionary time honing the composition of their shell to make it deflect predators, to make it strong. So it's like having armor, right?
Each time scientists visit these volcanic worlds, over half the animals they find are unknown to science.
Here's this little animal that sits in this warm water that's coming out, that's metal rich, and it's sitting there mining these metals. That is extraordinary.
Super snails and precious metals are just a tiny fraction of the riches we owe to the machine below. The volcanic activity of the mid-ocean ridge creates the black smoker fields and new ocean floor. As this new seafloor spreads out from the mid-ocean ridge, the seabed buckles and causes massive undersea movements and landslides. Usually this violence has no effect on our daily lives, until the internet goes down. 99% of all our internet traffic between the continents is carried by undersea cables. These cables run from the land, across the continental shelf, down and across the ocean floor. In December 2006, 9 fiber optic cables between Taiwan and the Philippines suddenly went dead. Computers across Asia crashed. Engineers soon discovered the cables had been severed. Beneath the waves, when the seafloor buckles, it causes underwater landslides. Just off the coast of Taiwan, thousands of tons of rock and debris from the continental shelf had been dislodged and snapped the cables. The internet across much of Southeast Asia was out of action. Economic disaster loomed. It took weeks to find and repair the cables. It's a task that requires a special kind of ship. This is the Wave Sentinel. It's one of a fleet of high-tech vessels whose job it is to keep the internet connected.
We cover North Sea, Irish Sea, English Channel, and basically halfway across the Atlantic. Well, the first thing I will hear is my bat phone will go. As soon as it does, the adrenaline's going and anxious to get out there and fix the cable.
Slack away!
The ship is ready to go at all times. We find out what cable it is, and we find... Excuse me, this might be important. Good afternoon, Wave Sentinel, Captain. get as much information as fast as we can and make a plan.
Under the plan, the crew of Wave Sentinel must head to the most remote parts of the ocean and risk life and limb to fix the cables quickly.
We've got to figure out the best place to grapple for the cable, where you're most likely to find it, where it's most likely to be buried. If the cable has been hit by a landslide, then it could have been knocked kilometres off route.
This is not easy, as the cables snake across the ocean floor at depths of over 4 kilometres.
I've got an excellent supportive team working for me. Couldn't hope for better, guys.
The cables going across the Atlantic don't go in straight lines. They follow contours of the seabed. They will snake their way across the Atlantic. They do get damaged by a lot of fishing activity, movement in the seabed itself.
The Wave Sentinel searches for the broken cables with high-tech remote-operated vehicles that can operate at such depths.
There is a lot of pressure on. The clock is ticking to get the repair done as quickly as possible.
Keep it nice and slow now.
When they find the ends of the broken cable, they're grabbed by the ROV and taken to a state-of-the-art operating theatre.
We cut out that damaged piece of cable and replace it with a new piece of stock cable.
Beneath layers of armour cladding, the business part of an internet cable comes down to this: an optical fibre no thicker than a human hair.
From one of these fibres here, we can get something in the region of 120 million simultaneous emails, unbelievably, or something like up to 150 million phone calls simultaneously. We melt the ends of the glass, push them together to make a continuous fibre.
Each repair can cost around £500,000, all paid for by insurance that all the global telecom giants and cable operators buy into. There are hundreds of landslides each year in the Atlantic alone, so there's plenty of work for the Wave Sentinel.
We could be called to cover the whole Atlantic, so we could be 10 days away from a site. Get on site, start work, and then 10 days back home again. We could be working at sea for 6 weeks at a time.
It's good having a understanding wife at home.
It's ships like the Wave Sentinel, its captain and crew, that keep the whole World Wide Web connected. Once the internet cables reach the deep ocean floor, they must find a path around the active volcanoes found there. There is more volcanic activity on the seafloor than on land, and some of the volcanoes can be big, very big. We think of Everest as the world's tallest mountain, but that record belongs to a mountain in the middle of the Pacific Ocean. The summit of Mauna Kea volcano on Hawaii sits over 4 kilometers above sea level, but it's another 5.6 down to the seafloor. Because the island is so heavy, it's made a huge dip in the seafloor, and that means the true base is another 8.4 kilometers further down. In total, Mauna Kea is over 17.5 kilometers high. That's twice the height of Mount Everest. From the tallest mountain to the deepest place on the surface. We've reached 4 kilometers below the surface, and most of the water that covers the seafloor has now been drained. But in order to reach the deepest part of the ocean, we must drain down another 6 kilometers. This is the Mariana Trench in the Western Pacific. At 2.5 kilometers long, over 11 kilometers deep, and 69 kilometers wide, this massive trench on the ocean floor contains the deepest point on the planet, the Challenger Deep. The pressure of the weight of the sea at this point is so great that it reaches 47 tons per square centimetre. Because of these formidable pressures, it needed a special vessel to reach the Challenger Deep. The Trieste, as it was called, had 12-centimetre thick walls, and its 13-ton pressure sphere hung under a tank filled with 85,000 litres of gasoline for buoyancy. The expedition also needed a special crew. 12 men have stood on the moon, but only 2 have been to the deepest place on Earth. Don Walsh, then a Navy lieutenant, was joined by Swiss engineer Jacques Picard for the dive. On the morning of the 23rd of January 1960, the 2 men climbed into the confined space of the research submarine Trieste to descend into the alien world at the bottom of the sea.
The space inside the cabin was about 38 cubic feet. Now the average household refrigerator, or the medium-sized refrigerator, has about that same capacity. And the temperature inside wasn't much different.
The great danger to the mission was the tremendous pressure at these depths. If the sub failed, the 2 men faced instant death.
The pressure is 8 tons per square inch, so in an area that size, you'd have 8 tons pushing down. And total pressure on the cabin was 200,000 tons, like 100 World War II destroyers piled on top of you. The cabin had collapsed. It had been so instantaneous, I'm not sure we'd even been aware of it. Tremendous pressures. It would just imploded. We used to joke about maybe our mothership topside, because we had to have escort ships, would just carry a load of flowers and they could just chuck them in the water and go home. So nothing could be done for us. At 31,000 feet on our way down, we had a huge bang. Just didn't know what it was. We looked at each other. We're still alive, looking at all the gauges. We were still proceeding normally. Everything was normal. So we said, well, hell with it. Let's just go on down, keep on going. There's a window in the hatch, and that had cracked.
After a descent of nearly 5 hours, they reached the bottom of the Mariana Trench, 11 kilometers below the surface.
We were in a spaceship, and it was like visiting another planet. Once we disconnected from the surface, it was like you were going through a void of space and then landing on an alien planet. And it was very much like that. After we surfaced, Jacques and I were sitting there waiting for the boats to come fetch us. And we were talking about this. When do you think somebody will be back next? And we kind of agreed between 1 and 2 years. That was a half-century ago. No one's been back.
The great depth of the Mariana Trench was formed by the collision of 2 oceanic tectonic plates. One has been forced down beneath the other, creating a huge dip in the ocean floor. Closer to land, where the seafloor collides with the continental landmass, the effects can be even more deadly. Enormous forces are generated that affect millions of people. Massive pressure builds up. Until sometimes Suddenly, it gives. This is what happened off the coast of Japan in March 2011. An earthquake beneath the seafloor created the devastating tsunami that hit Japan just minutes later. The Pacific region is very unstable, so quakes and tsunamis are frequent. 7 years earlier, there was an even bigger quake and an even more destructive tsunami. On the 26th of December 2004, Indonesia was hit by a devastating earthquake that came from beneath the seafloor. Just off the coast, the seafloor was ripped open. In a matter of seconds, part of the seabed shot up 5 meters. This quake created a terrifying tsunami. Around Southeast Asia, more than 200,000 people died. The earthquake was so powerful, it shifted the Earth on its axis, shortening our days by 2.68 microseconds. The North Pole is now nearly an inch to the east. On the virtual Earth, we can hear what the Indonesian earthquake actually sounded like. As it vibrated, the Earth rang like a bell. The enormous power of the Indonesian earthquake is evidence of the seafloor colliding with the land. It's what the Earth machine does next that has an equally powerful effect. As the seafloor bumps up against the land, it has nowhere to go but down. It's a process called subduction. This collision between the seafloor and the land creates enormous pressure. As the rock falls down into the mantle, it begins to melt. Some of this molten rock rises up through the cracks in the land above. The magma eventually erupts onto the surface. Along the coast of South America, it creates a chain of over 200 volcanoes. Further up the coast to the USA and Alaska, there are over 50 active volcanoes. Down around the coast of Russia, Japan and China, there are hundreds more. This line of coastal volcanoes is known as the Pacific Ring of Fire. One of the most extraordinary volcanoes among them is here on the island of Java in Indonesia. Volcanoes cause havoc and destruction, but they also bring great riches to the surface of the Earth. They bring valuable minerals and release vital gases that help create the air we breathe. At Kawah Ijen volcano in Indonesia, you can witness one of the most extraordinary sights created by the Earth machine. This is liquid sulfur burning within the crater of the volcano. These liquid rivers of burning sulfur are the remains of old seafloor melting over 90 kilometers below the crater. Sulfur is one of the most important chemicals for industry, but it is also one of the key minerals needed for life on Earth. Sulfur is used in everything from medicines to fertilizers, vulcanizing rubber, and even for making your sugar that perfect white. Dawn over Kawah Ijen. Inside the crater, the poisonous gases make this one of the most toxic environments on the planet. If we could drain the water from the oceans, the seabed might look a little like this. It's dangerous and dirty, but volcanoes like this give us direct access to raw sulfur. Sulfur is a valuable resource. So every day, hundreds of miners descend into these fumes to hack out the sulfur. The gases are so corrosive that the men can only spend a brief time in the crater. They have a short life expectancy. Sulfur pours out of the ground at 600 degrees centigrade. Then solidifies. Teams of miners bring up tons of sulfur every day, the hard way. The powerful forces that bring valuable minerals to the surface are a visible part of the enormous cycle of renewal and destruction of the seabed. If we open up the Earth on our virtual planet, we can see this subterranean process. As the seafloor spreads out from the mid-ocean ridge, it meets the continental landmass. The heavier rock of the seabed is forced downwards. Some of the seafloor melts and falls in huge folds over 2,800 kilometers through the mantle. As it falls, it helps pull the rest of the plate across the face of the globe. Beneath the mantle is the core. This is the source of the heat energy that drives the Earth's machine. The core is even hotter than the mantle. As the melting seafloor reaches the core's outer surface, it is superheated and rises back up in vast plumes towards the surface. It's a continuous cycle driven by the Earth's machine. This machine has an incredible effect on our lives. It moves the continents, builds the highest mountains, and creates the deepest place on Earth. The seafloor spreads from the mid-ocean ridge to where it collides with the land. It's the heat at the center of the Earth that drives the whole cycle of the seafloor. Yet what is the role of the water itself? What would happen if the Earth really did lose its oceans? Well, now we can show you. Without the weight of the water, the unzipping of the mid-ocean ridge would be incredibly violent. Vast sheets of lava would explode into the sky. Without the weight of all that water to shear up their sides, the continental shelves would collapse. Mudslides and dirt avalanches bigger than anything seen before would be unleashed. Massive pockets of methane gas would explode. All this would cause hundreds of devastating earthquakes. With no water, there would be no weather. No rain. The entire planet would become a desert. There would be nothing left alive. However, this is not going to happen because the water in the oceans keeps the lid on the volcanic activity on the seafloor. This is how the Earth machine works. Heat from the inner core creates the biggest geological formations on the planet and helps drive the movement of the seafloor to release vital minerals and gases. And without these processes, there could be no life on Earth.